Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 23, 2025, about 1 day ago. It introduces SpatialTree, a 4-level hierarchy plus a benchmark across 27 sub-abilities, and it finds a surprisingly clean pattern where level 1 perception skills stay mostly independent, while higher level skills become strongly correlated and interdependent. The paper is titled SpatialTree: How Spatial Abilities Branch Out in MLLMs. Okay. And the implications for how we fine-tune and do reinforcement learning across perception and reasoning are quite significant. Figure 1 explains what SpatialTree means in practice, namely that spatial intelligence grows from basic perception into full-blown action. The whole diagram lays out 4 levels, so the key idea is a capability ladder rather than a grab bag of tasks. In the lower right, level 1 perception covers things like distance, motion, and relations, which are meant to be more direct visual skills. Higher up, level 3 mental simulation, and level 4 agentic competence shift toward planning and execution, which depend on those lower-level signals. Figure 2 makes the key point that the same word, relation, changes meaning as you climb the spatial tree hierarchy. The full figure lays out 3 panels. Each one is a different kind of relation question. Panel A stays at level 1 perception, so it is about a simple inside versus outside judgment. Panel B shifts to level 2 understanding, which adds object attributes and relationships. Panel C moves to level 3 causal reasoning, so the model must compare viewpoints and justify the conclusion. Table 1 turns the hierarchy into a leaderboard, so it tells you which models actually hold up across perception, mapping, simulation, and action. The bracketed weights mean the overall average emphasizes some sub-skills more than others, so the AVG column is a weighted score. The dark gray cells mark the best overall results, and Gemini 2.5 Pro leads the average with 50.1. The light gray cells highlight the best open source scores, where Gwen 3 VL 235B is the strongest overall at 40.0. Figure 5 shows that spatial skills in multimodal large language models cluster into a real hierarchy, rather than improving independently. Pearson correlation means a score that rises when 2 abilities tend to get better together across models. The full heat map in Figure 5 summarizes all pairwise dependencies. Region A groups level 3 and level 4, where many cells are strongly positive because planning and action share subskills. Region B covers level 1, where correlations are weaker so perception skills act more separate. Table 2 shows that fine-tuning one level 1 perception skill can unintentionally harm other level 1 skills, even while helping higher-level reasoning and action. The table highlights the full results grid, where each row is a different supervised fine-tuning recipe, and each column is a capability score. The B plus distance row boosts geometry but drops relation and localization, which is that negative within level transfer. The combined distance plus size plus correspondence rows recover and improve more broadly, suggesting multi-skill tuning reduces interference. Table 3 shows that reinforcement learning helps most when it matches the cognitive level, instead of forcing the model to always think a lot. Reinforcement learning with verifiable rewards means the model gets rewarded by checkable signals, so training can be more reliable than subjective judging. In the top block, full RL at think lifts the average, but it also hurts the mapping and planning scores. In the lower block, full RL at auto-think improves the average and boosts open exploration strongly. Alright, 2 takeaways stand out. SpatialTree gives a practical hierarchy for spatial intelligence, where level 1 perception stays fragmented, but higher-level reasoning and action rise together. The training result also matters, because supervised fine-tuning can cause interference within perception, while auto-think reinforcement learning improves broadly by avoiding pointless deliberation. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.